Assalamualaikum and a very good day to panel and my supervisor, Dr. HAZWANI BINTI MOKHTAR. My name is Zaimul Kahar from BMMV S1/1. I'm going to present my PSM1 presentation, and my project title is about design, development and flow analysis of shower for bedridden, elderly and patient. So we go through the first chapter is introduction. So background. First point of background is several people above the age of the 65 are bedridden to the age-related problem. Number 2 is ordinary people also the first to be bedridden to the various problems such as paralysis and vaccine accident. Number 3 is unable to perform patient's first safe care and immediate treatment and require the support from others. Number 4 is a need 24 hours resistant and intensive care. Number 5 is a need extreme caution about their activities for ensuring and enhancing the quality of life. Next, problem statement. First point of problem statement is giving a bed to the bedridden patient is very limited and burdensome for both caregiver and a bedridden patient, and is required caregiver effort to perform the operation. Number 2 is the current method that a caregiver used for giving a bed to a bedridden patient is a conventional method, and this method makes the time taken to give a bed to the bedridden patient longer. Number 3 is generally there are less contribution to the bedridden community. Okay, next, research objective. First point of research objective is to design a new model to easy shower for bedridden patient. Number 2 is to analyze the performance of design model of easy shower for bedridden patient by simulation method. And number 3 is to evaluate the different volume velocity set the design model of easy shower for the bedridden patient. And then lastly, scope of research. This study will use simulation process to design and analyze the design shower and evaluate the different volume of velocity set with a design of the easy shower for the bedridden patient. So we go to the next chapter, literature review. What I found from the research is about a bed bathing. Downey and Leod 2008 stated that bed bathing can help manage the hygiene need to bedridden patient. They put two statements which are: first, cultural awareness and personal preference, which a caregiver should consider patient preference so that the bedridden patient will be in comfort condition. Second is privacy and dignity, which are confidential and invasive procedure, and patient may feel uncomfortable or even irritated. Next, there are three of statement what I found from the research. Firstly, communication. Significant interaction allow the caregiver to engage in the helpful conversation and consult any sensitive and complicated problem that may occur. Number 2 is assessment. Offer opportunity for caregiver to evaluate health practice of a bedridden patient. Would use this interaction to find out about the patient health condition, sleep habit and pain perception. Number 3 is a risk assessment. Important to make sure that all appropriate risk assessment are undertaken before a bed is performed. So next slide is portable bathtub. For this to enhance self-esteem and muscle relation, portable bathtub offer comfort and well-being. Portable bathtub enable advancement in enhancement and humanization in nursing care. Portable bed is provided the nursing staff profession with a greater cooperation and gratification. Next, portable washing system. For this research consists to main device plugged into the supply of electrical current. Water is heated, storage and pumped to the top, and a bed with an outlet for the water flow and mounted on the bed under the patient. Constant water temperature control is about 38 degrees Celsius to the 42 degrees Celsius. The average flow rate of the 5 liter per minute per moment in about 8 minutes and 22 minutes, using the power of a 3 kilowatt of the system. And caregiver have the product ready to give a bath in 30 minutes. So lastly, for this chapter review, is a computational fluid dynamic (CFD), an analytical method for a rapid efficient simulation of a fluid flow and heat transfer. Can design fluid flow by mathematically resolving and using fundamental equation. Our results are visually displayed, and then common software used for CFD analysis is SolidWorks, easy to use and has many tools. So we go through the next chapter, which is methodology. For the first slide is my survey question, which are 5 questions of the demographic, 10 questions of the marketing, and 11 questions of the product specification. We go through the next slide, which are concept design. For the first concept is a show a hygiene of the bedridden patient. This concept is for shower from the above using speaker circle to make comfortable and hygiene for bedridden. This concept is easily to move whole body patient or bedridden from the bed place to the replace. This concept when shower is simple and easily to using it. This concept is friendly user can affordable because the cover using material fabric and can break everywhere. Then the concept number 2 showing design does not change too much from the first concept, but it has to change position from the above to the bottom. The function speaker on the bottom is to make is a nicely shower because it can adjust the flow rate pressure. The same the first concept simply but easy to use with additional safety sensor. If patient or bedridden move their body, then the speaker automatically stop. Then the last one concept number 3 is a show the third concept similar with the first and second concept. This concept the patient and the bedridden is sitting on the chair by fastening with a bed provided. Same the function of shower from shoulder to toe. This easy to bring everywhere, and the cover of the material is a fabric or canvas, so it can foldable. So the next slide is a weighted decision matrix result. So we can see the table showing a result from the respondent. Total score for each design can be obtained after all the value and keep in, and the value of each design is given to consider all the design criteria design A, which means the first concept has a highest total score because the product is easy to use, easy to handle, and simple design and low cost. For the next slide is a figure of my simulation of flow rate during final concept. So the next slide is final design. Design A obtained the highest score and had been chosen as the design that will be on simulation. There are some modifications that had been made on design A. For the final design, it still have 1 water inlet and 7 water outlet, but the position water inlet and different position of the water inlet. Modification has been made for improvement on the water pressure. And the water pressure is transferred from the supply water into the pressure pipe to the transfer the outer out of the speaker, and the material has been made by making the water inlet is same as water outlet. For the water outlet design model, there will be hose connected to inlet of the model design. So next slide is a flow simulation. Simulation of model design will be made by using SolidWorks flow simulation. 2 simulation conducted on the model. First simulation is simulation of water inlet. Second is a simulation of water outlet. Model of the 2 simulation is same by addition to the simulation of water outlet. It has to be hose connected to the inlet of the motor design. Simulation of water outlet included with a hose connected. Next is a boundary condition. This table showing the data of the boundary condition, water inlet and water outlet. So we can see the data is same, velocity on x-axis is different. Water inlet is 5 meter per second, meanwhile water outlet is 0.5 meter per second. Okay, why I put on x-axis? Because the flow on the drawing is started from x-axis. Next is a parameter of the design model. Parameter that has been set on this design is velocity, and for each simulation there will be a different value of the velocity that is set as a parameter on the model design, which are 0.5, 2, and 5 meter per second. So for the last slide, for this chapter is regular parameter of boundary condition water inlet set with the different value of velocity for each simulation, and boundary condition water outlet set with the different value of the velocity for each simulation. Okay, we go to the next chapter, which is preliminary result. For the first slide, I want to share about data collection of survey. The survey method is by using Google Form. The survey question are disputing to social media like WhatsApp, Facebook, and Instagram. All the collection data are exported from CSV file, and it is transferred directly to Excel. The time to obtain 102 respondent result take almost 2 weeks. So the first data is demographic data, and then the second data is the marketing, and the third data is product specification. So the next slide is specific total rating, rank, and rating. This section including the 4 and 5 rating were calculated by analysis to determine the specification rating. The survey results show the top 5 specifications were cleanliness of patient, easy to handle, strength, ergonomic, and durable material. However, the lightweight specification is on the bottom. In other words, the respondent preside comfort and easy to carry is over the weight. So next slide is simulation test. There are 2 simulation tests, and in the simulation test there will be another 3 simulation tests for different velocity volume. The first simulation test is on the water inlet, and the second water inlet of the model design, and each simulation test is start with the first value, which is 0.5 meter per second, and then 2 meter per second, and then lastly is 5 meter per second. Before I got the result of flow simulation, I do a model with a meshing first to get a nicely when doing analyze flow simulation. So we go through the result of flow trajectories. For flow trajectories in velocity of water inlet, 0.5 I got 0.708 meter per second. For 2 meter per second, I got 2.085 meter per second. And then lastly, for 5 meter per second, I got 7.495 meter per second. And then for flow trajectory in pressure, for 0.5 meter per second, I got 102,001.74 Pascal. And then 2 meter per second, I got 11075.05 Pascal. And lastly, 5 meter per second, I got 161,561.48 Pascal. For water outlet, I pick average value from first sprinkle and the last sprinkle. For the flow trajectory in the velocity of water outlet, which are 0.5 meter per second, is 7.107 meter per second. 2 meter per second is 28.405 meter per second, and lastly for 5 meter per second is I got 72.016 meter per second. And then for flow trajectory in pressure of water outlet, which is 0.5 meter per second, 99244.79 Pascal, and then 2 meter per second I got 67831.72 Pascal, and then lastly for 5 meter per second is I got a negative 74653.51 Pascal. It's because the water outlet has no pressure on environment pressure. And then lastly, conclusion. What I got is the studying finding could be applied on the determining this suitable velocity for giving a bed to bedridden patient. And then this help research to develop a bedding mechanism or a shower kit for the bedridden patient with a suitable and convenient velocity. Additionally, a bedding mechanism or an easy shower is developed to make the process of giving bed to bedridden patient is easier. On this slide, I include with 11 reference what I researched on this project PSM 1. And then for the last slide, I include to with Gantt chart what I have done from week 1 to week 14. So thanks for watching and thank you.